All right, so let's look at another test, testing a claim about a mean. Again, sigma is unknown, so we remember if sigma is unknown, then we're going to be using the t-score as our test statistic. But in this situation, we're going to be doing a two-tailed test. All right, I'll tell you why that's the case. Um, but let's get started. So what we're looking at is we're looking at the depths of earthquakes. Okay, and the null hypothesis is this: that the average depth of earthquakes is 5 kilometers. But we're not sure that's correct. And so our alternative hypothesis is that it is not equal to 5. We don't know if it's more than 5 or if it's less than 5, but we think it is not. We just don't think it's 5. Okay. Now, this right here is important because this is why it is a two-tailed test. If your alternative is ever that it is not equal to, that the mean is not equal to a value, then you're dealing with a two-tailed test. Okay, otherwise it's a one-tailed test. I'll show you how that comes into play here in a little bit. All right, we're going to run this test at an alpha level of 0.01. Okay, so in addition, so we go out and gather our data. So we looked at 600 random earthquakes, and they had an average of 5.82 and a standard deviation of 4.93. This is the sample standard deviation. So we don't know sigma, we don't know the population standard deviation. Again, t-score. So there's our sample data. So the first thing we do is we find our test statistic, right? Our test statistic, which is the t-score. And here's our formula. Again, same as always. And so in our case, it's going to be the sample mean that we got minus the claimed mean over the sample standard deviation divided by square root of 600 of the sample size. And so when we plug that into our calculator, that is the t-score that we get. Okay? So once you have your t-score, you calculate the p-value. And remember, this is how it works. In order to calculate the p-value, let's write this down. Now, this is where I'm going to put an asterisk here because it's in calculating the p-value where the two-tailed test differs. Okay? So here's how it looks. When I draw the picture, the claim is that the mean is 5. But here's the deal. In a two-tailed test, if we get a value that's way higher than 5, then that supports our alternative hypothesis. Or if we get a value that is way lower than 5, that supports our alternative hypothesis. So what we need to do is we actually have two cutoff points, two symmetrically placed cutoff points, okay? And so what we want to do is we want to put our value right here, 5, or sorry, not 5. Our t-score is right here, and its opposite is right there, okay? So I'm still going to find this area. And I actually don't really pay attention to this opposite, except that it does provide the symmetry that we need. But in reality, put your sample right there at that cutoff, and you need to find the area, okay? So again, to find the area of that, we have to use technology. If I want to find the p-value, I have to use technology to do that. So we're going to use the tcdf command, you'll remember. And so it's going to be our lower boundary. It's going to be, well, let me write it down. This is what you should be typing in your calculator. TCDF. Actually, find that under the distribution menu. Your lower boundary is 4.07. Your upper boundary is going to be some big positive number. And then our degrees of freedom is 599. So that's what we should be typing in to our calculator. And that gives us a p-value of, not a p-value. It gives us an area. So notice I didn't call it the p-value. In the past, I called it a p-value because that was one-tail test. The area was the p-value. But I'll explain the difference here. So I get 2.665 times 10 to the minus 5, right? So that is 0.0000265. That's the area. It's tiny, right? Now, here's the big thing you want to remember. Your p-value in a two-tailed test is 2 times this area. Okay, so that's the big thing. Find the area and multiply it by 2 in a two-tailed test, and that is your p-value. Okay, in a one-tailed test, you don't have to do that. In one-tailed test, you just take the area. Okay, but that's the big difference in a two-tailed test. Find the area, multiply it by 2, because you're actually needing to include this area right here in order to calculate the p-value. But nevertheless, once we do that, we compare, right? You compare the p-value to the alpha level, and I think our alpha level was 0.01. And we are clearly less than that, so we will reject the null hypothesis. It seems that we have evidence that the mean depth is not equal to 5. Now notice, because our alternative claim was that it was not equal to, we can't say, oh, we think it's bigger than 5. We can't change the rules. All we can say is we think it's not equal to 5. Okay? And so that's a two-tailed test when sigma is unknown when we're testing means.